Okay, geometry students, this is chapter 11. We're going to be talking some more about circles. This one's not so bad. We're going to be talking about circumference, and I know we all know the formulas for circumference, but then we're also going to be talking about arc length. So let's just jump into the vocab. Again, this one shouldn't take us very long. Vocab, it says the circumference of a circle is the distance around the circle. Okay, circumference is essentially same thing as perimeter, if you will. When we talk perimeter, we talk about the distance around some enclosure or some space, and so circumference is just the special name for perimeter of a circle. Okay, arc length. Arc length is a portion of the circumference. So we're essentially going to be dealing with like a portion or a subset or a percentage, if you will, of the circumference of a circle. Okay. And then, of course, Theorem 8 gives us the two formulas that we know for circumference, which I'm sure we are all very familiar with. Circumference is either pi times diameter, or circumference is 2 times pi times radius. Now, why is that? Because of course we all know diameter equals 2 times radius. So if you have the diameter, great, just take it times pi. If you have the radius, you have to multiply it by 2 to essentially get the diameter, then take that times pi. Now, one thing I want to point out here, there is a difference. On most of our homework today, they want us to actually like use a calculator. I know that in earlier years of school, they have told you, the approximation for pi is 3.14, and that's true. However, I highly recommend that you use the pi button on your calculator. And so technically pi is like 3.141592654, blah, 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 blah. There's people that have pi memorized to a bazillion places, and good for them. But use the pi button on your calculator so that you don't have any rounding issues. Okay, I highly recommend that, number one. Number two, we have to be careful in our homework, and I'll point out to you specifically a section that when it asks for an exact answer, they don't want you to do any rounding. If they ask for an exact answer, they want you to leave the pi symbol in the answer. Okay, so a couple things I just wanted to point out. Use the pi button instead of just 3.14 if you're poking it in your calculator to approximate. And if they say exact, they want you to leave the pi symbol in the answer. Okay, because anything else that we write down is going to be an approximation if we use the pi button in our calculator to turn it into a decimal. Okay, now arc length corollary. Next thing on our vocab box here. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. Okay, so for instance, let me quickly here draw a circle. Okay, if this is our R, okay, say I want, okay, first of all, notice I put a little box there. That's 90 degrees, okay? That is also 1/4 of the circumference, okay? So on this, if I'm trying to find this arc length, I hope you all can see the purple here, okay? If I'm trying to find the arc length of this purple, what this corollary is telling us is that essentially it's equal to the ratio of the measure of the arc to 360. Okay, so if I knew the R, if I knew whatever the radius was, and I calculated the circumference of the whole circle, this arc length that I'm drawing here in purple is going to be 1/4 of the circumference. How do I know that? Because I know 90 over 360 is 1/4. So the arc length there that I have shaded in purple is going to be 1/4 of the circumference. That's what they're talking about. Okay, that's the ratio they're talking about. We'll do some more of those as we go. Okay. First, let's just kind of focus on circumference. And so on this example 1, it says, find the indicated measure. So circumference of a circle with radius 11 feet. So notice they just came here, used the formula, and then poked in 11 in place of the r. Okay, now what I want to point out to you is this is the exact answer. So if you get to a point of your homework, and again, I'll point it out to you again, and they want exact, this would be your answer. This, notice the squiggly bars, okay, is approximation. Okay, that is rounded. Okay, it's an approximate answer. So exact, they use the pi symbol. Approximately, you know, most of these we're rounding to the hundredths place, 2 places behind the decimal, but just kind of wanted to point out to you. Equals, again, versus the squiggly equals, which is, I don't know if they have an exact name, I just call them squiggly. That's approximate or rounded, okay? Now, I will give you the heads up that further on, if you all are going on to take trig or whatever, a lot of times they want exact answers. So you're going to be used to writing pi in your answer. So that's another reason why I wanted to point it out. Okay, the next part B, it says diameter of a circle with circumference 75 meters. So now this is the formula we have for circumference when they give us diameter. And notice we're just substituting in the 75. Well, then, of course, to solve for D, you got to divide off the pi. So again, this would be exact, okay? This would be your approximate answer. And I don't know, for some reason my handwriting didn't come out very well, but that's your rounded, okay? All right, let's look at the exercises for example 1. It says use the diagram to find the indicated measure, okay? So right off the bat, I'm thinking C equals, nope. They gave me diameter, so it would just be pi times diameter, right? So this is going to be pi times 16, okay? 16 pi would be my exact answer. That is approximately 50.27 when I poke it in my handy dandy calculator. And again, you have to label, this is inches. Okay, approximately 50.27 inches. The exact answer would be 16 pi. Okay, exact versus rounded or approximate. The next one, they want us to find the radius. They give us the circumference. So now we're going to be using the formula C equals 2 pi r. Okay, well, I'm putting 35 in for the C. So 35 equals 2 pi r. So my r is going to be 35 divided by 2 pi. Okay, now again, that would be my exact answer. Since 35 doesn't divide by 2, I can't really do anything else with it. However, my approximate answer for r is 5.57. And 5.57 what? We were talking yards. Okay, now something I also want to point out, if you are poking this in a calculator, you need to be careful. Every calculator is a little different. If you've got 2 things that you're dividing by, keep in mind you need to put that in parentheses. Okay, because if you just put in 35 divided by 2 times pi, it's literally giving you 35 divided by 2, getting the answer, and then taking the answer times pi. That's not what you wanted. If you didn't want to use parentheses, you would literally have to poke in 35 divided by 2 divided by pi. Okay, you'd have to do the division twice to get them both on the bottom. Just want to point that out. Third one here. They, again, want circumference, but now they didn't give us diameter, they gave us radius again. So once again, we're using the equation 2 pi r, okay? So that is 2 times pi times 4.5, or 9 pi would be my exact answer, 4.5 times 2, okay? Approximately that is 28.27, and that is centimeters. Okay, I hope that's pretty straightforward and clear. Let's move on to the back. Now we're talking about arc length. Okay, now this isn't the measure of an arc. The measure of an arc, remember, is that central angle. Okay, this is arc length. We're talking about when they say the length of AB, they are talking about physically that part of the circumference that's just from point A to point B. Okay, that's what they're talking about. So arc length of AB, okay, we are taking the ratio of the measure of AB, okay, that central angle, over 360, okay, equals, or sorry, well, you can set it up as a proportion. They'll do that in the next step. So times the circumference. So that fraction times the circumference. Okay, so in this case, notice this is the measure of arc AB, that central angle is 150, over the circumference. Sorry, I apologize. Over the angle of the whole circle times the circumference. Okay, so this is the central angle or the arc measure AB. Can't hardly see my B there. Over, this is the measure of a circle. Okay, the 360 we know is the degrees in a circle times the circumference. Okay, now let's look at some of these on our own. I'll try not to misspeak. Find the length of AB. Well, this one kind of goes hand in hand with the little example I showed you for the arc length corollary on the front page, but 90 degrees. Okay, so again, we are taking our ratio of our arc length times the circumference. Okay, so let me just write that. Times circumference. Okay, or in other words, it is going to be the measure of your arc length, okay, over 360 times C. Okay, that essentially is our formula for this. Okay, that's our formula. It's the measure of that arc, that's the central angle, over 360 times the circumference. Okay, so we've got, for number 4 here, we have 90 over 360 times, our circumference is going to be 2 pi times 15, because 15 is our radius. 2 pi r, remembers, our circumference. Okay, so if we do that, obviously this is like 1/4 times, actually let me go ahead and do 30 pi. Okay, 1/4 times 30 pi, okay, which is 9 pi, no, sorry, 15 pi, it's like Monday to me or something. 15 pi over 2, okay, that would be the exact, all right, but that is approximately 23.56, and again, we were measuring in feet. And again, there's my dead spots on the board. Okay, 23.56 feet. Okay, so again, measure of your arc, okay, that's central angle measure, over 360 times the circumference. So number 5, again, 5, we're looking for this, okay? So that is 40 over 360 times, again, my circumference is going to be 2 pi times 6. Okay, so 40 over 360 reduces to 1/9 times 12 pi, okay, which is 4 pi over 3, which is approximately, which you could just poke this in a calculator from the beginning, I guess, 4.19 meters. I'm used to giving exact answers in my upper level classes. So you could have just poked the 40 over 360 times 2 pi 6 into a calculator at the very beginning. I'm just used to reducing. Okay, last one here, number 6 on this part. So here we're doing, again, we're finding arc length of AB, okay? So arc length of AB, that's that purple shaded, okay? So that is 150 over 360 times, here they give us the diameter. So it's just 34 pi, all right? And for the sake of time, I'm just gonna go ahead, I'm not gonna reduce, I'm just gonna write the answer. 44.51 centimeters. Okay, hope you all can see that. 44.51. Okay, now we can also, you know what, I didn't really highlight this arc length, I guess I should. Okay, now we can use proportions, okay, to solve some of these others. So look at example 3 here. It says find the circumference of circle Q, okay? Now, here is how the proportion is set up, all right? Arc length over circumference equals measure of the arc over 360. So again, we're setting up a proportion with the piece of the circle, the arc length over the circumference of the whole circle equals the piece of the central angle, the piece of the circle, the central angle or the arc measure over 360, which again is the arc measure of an entire circle, okay? So we've got our parts on top and our totals on the bottom, if you will. Okay, circumference is the perimeter around a whole circle, and 360 is the angle measure of a whole circle. Those are on the bottom. Then we have the pieces on top. Okay, so they have that set up nice and neat. Let's look at these exercises and do them together. I think it'll make a little more sense. So find the indicated measure, AB. Okay, here's what I'm looking for. I'm looking for this measure. Okay, measure of AB is the central angle. Okay, not the arc length, it's the central angle. Okay, so you have to be careful which one they're asking for. Okay, and what's labeled and what's missing, if you will. So in this case, we've got arc length. Okay, so let's do, let me set this up. Arc length over circumference equals, well, I don't know if I want to call it central angle or arc measure. Let me do arc measure. Over 360. That's how we set up our proportions. Okay, this is the basic setup. Okay, arc length over circumference equals arc measure over 360. So what do we have? We have the arc length is 18.84 over the circumference. We can find the circumference, right? They give us the radius of 9. So 2 pi times 9 equals my arc measure. Remember, this is how we do arc measure. That's the symbols for it, how we write it, over 360, of course, we know is the arc measure for an entire circle. Okay, so again, we've got our pieces on top, corresponding arc measure and arc length on top, and then on bottom we have the measures for the whole circle, the circumference and the 360. Okay, cross multiply. Okay, that's all we have to do here. So if you, well, let me go ahead and draw. Remember, we are going to start by multiplying that and then dividing by the odd out. So 18.84 times 360 divided by 18 pi is going to equal the measure of arc AB. Okay, if I poke that in a handy dandy calculator, I get approximately 120 degrees. Okay. Now again, be careful if you're poking this in a calculator, you're going to need parentheses around anything you're dividing by. Okay, be forewarned on that. Okay, let's look at the next one. Now we are trying to find the radius. Okay, so we are trying to find this, our radius. So that's part of our circumference. So let's set up our proportion. They give us our arc length and our arc measure. So arc length is 1.57 over circumference, that's where our r is going to come in, right? 2 pi r equals arc measure is 45 degrees over the arc measure of the whole circle is 360. Okay, so once again, we are going to have, if we do our cross multiplying here, right? So we've got 360 times 1.57 equals 45 times 2 pi r. So r is going to equal 360 times 1.57 over 90 pi. 45 times 2 is 90. So that gives us an r of approximately 2 feet. Okay, poke that in the calculator. All right, I should have probably put that 2 on the other side, but that's all right. Now we're trying to find circumference. So again, we're setting up our proportion. Okay, setting our two ratios equal to each other. So we are trying to find circumference of the whole circle. Okay, whole distance around. Now let's start with, if I look over there in my box at my basic setup, arc length here is 41.87 over circumference is what I'm looking for, equals, okay, arc measure is 200 over 360. Okay, so if you poke that in a calculator, 360 times 41.87 divided by 200, your C is going to be approximately 75.37 centimeters. Okay. Again, remember, this is these two divided by that. So you have 41.87 times 360 divided by 200. Okay. All right, hope that's helpful. Let's look at practice A. Just do a couple of problems from it. It's pretty straightforward. Practice A. Again, use the diagram to find the indicated measure. So find the circumference. Remember, we have two different formulas for circumference. Okay, we've got circumference equals pi times diameter, and we have circumference equals 2 pi radius. And that's only because the diameter equals 2 times the radius. So on this one, they give us the radius. So our circumference equals 2 pi times 7, which is 14 pi. That, again, would be my exact answer. If I poke that in the calculator using my pi button, I get 43.98 centimeters. And I know they don't necessarily tell you to round to the hundredths, but I'm telling you, as I looked at the answer key for these, almost all of them are rounded to the hundredths. Okay, now this next section is where I wanted to point out. Notice exact, 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 exact. Okay, what they're looking for is the use of pi in the answer. They don't want you to poke it in a calculator using the pi button and getting a decimal approximation. Okay, this is how you do most of your work in further classes. Okay, so if we look at number 4, for instance, we need to find the exact radius of a circle with a circumference of 36 meters. Now again, circumference equals 2 pi r. So for us, that is 36 equals 2 pi r. So that means that r equals 36 divided by 2 pi. Okay, well, 36 divided by 2 is 18, and then you've still got the pi on the bottom. That would be your radius as an exact answer. Oh, and I need to label it. That is meters. Okay, 18 over pi meters. Okay, hope that's helpful. So again, be on the lookout. If they say exact, they want you to use pi in the answer. Now, 8 through 10, it says find the length now, not arc measure, that's the central angle. They want the length of arc AB. So again, this is similar to others we've done here. They want this, okay? Well, this means it's 90 degrees, right? So the arc length, if you remember, is just taking your ratio of your central angle, your arc measure over circumference times, your arc measure over 360 times the circumference. Why do I keep screwing that up when I say it? I apologize. So let me write that again. So this is arc measure over 360 times circumference. Okay, remember that's kind of the basic formula. So this is going to be 90 over 360 times our circumference. We've got a radius of 7, so that's 2 pi times 7. Okay, so this is 1/4 times 14 pi, or 7 pi over 2 would be the exact answer. Okay, that is approximately 11 inches. Okay, if you poke that in a calculator. And round, it actually rounds up to 11.00. Okay, next part, 11 through 16. Says, in circle D shown below, angle ADC is congruent to angle BDC. So we know that this angle is congruent to that angle. Okay, I'm going to jump ahead here. Let's look at 16. So they want the length of BAC. That, remember, is a major arc, so they use 3 letters to name it because it's greater than 180 degrees. Okay, this is arc BAC that they're looking for in 16. Now, how could I find, first of all, that central angle of that major arc? Okay, well, I know the whole, let's go back up to my purple angles here. I know that if I take 360 and subtract 40, I get 320. So I know that BDC, this one, and ADC, this one, have to add up to 320. And I know they're congruent. So if I divide by 2, okay, what does that give me? If I divide those by 2, I get 160, right? So that means this is 160 degrees and this has to be 160 degrees. Okay, I hope that makes sense. So if I set up my proportion here for number 16, 160 plus 40 is going to give me 200. Whoa, not sure what happened there. 200 over 360. Remember your basic setup again is arc measure over 360 equals arc length over circumference. Let me write that again. Arc measure over 360 equals arc length over circumference. Okay, so now back to our problem. Our arc measure is 200, that's the 40 plus 160, over 360 equals the length, that's what we're trying to find, okay, length of BAC over the circumference. Okay, they give us a radius of 4, so that is 2 pi times 4. Okay, if I poke all that in a calculator, okay, remember I'm going to multiply the diagonals, the 200 times 8 pi, and then divide by 360. That is going to give me an arc length of approximately 13.96 inches. Okay, hope that's helpful. For some reason that looks like an N and not an H. Okay, let's go to the back page. Really the only one I want to do back here and kind of help you with is 20 and 21. Couple things I want to point out here. This should be find the perimeter of the shaded region. Okay, they kind of left that word out. I think it's kind of intuitive when you look at it, but just wanted to make sure. So what I need to do here on number 20 is we are essentially finding the area, sorry, not area, perimeter. We are finding this perimeter. I didn't trace that very well, but you all get the idea. Okay, so this is essentially half of a circumference, and this is half of a circumference. Okay, now would you all agree that it looks like the diameter here is 9? Okay, so that's diameter. Okay, so half my circumference equals 1/2 pi times 9. Would you all agree with that? Now, but I've now got 2 of them. Okay, so essentially a half times 2 goes away. So I have 2 of those because I have this half and I have this half, and they're the same size circle. So that's essentially like 1 circumference. So 1 circumference, okay, is just going to equal 9 pi. Then I have to add to that, I've got 15 here and I've got 15 here. Because again, they mark them to where they're congruent. Do you see that? Okay, so then I'm taking my 9 pi and I'm adding 15 plus 15, or 30, which is approximately 58.27. Now, they didn't tell me what the distances were measured in, so I guess I'm just leaving it 58.27. Okay. Wanted to just give you a heads up on that. I think everything else is pretty straightforward. Do what you can, okay? So this should get you a good start here on section 11.1. All right.